Hi everyone, I am Dr. A.C. Rajavil, Associate Professor, Department of ECE, SNS College of Technology, Coimbatore. In this lecture video, I am going to discuss about the topic 8051 architecture and its internal units for the subject microcontroller and its applications. First, we will see why we go for 8051 architecture. 8051 architecture are single on-chip computers because they have its own storage device as well as I/O circuits because it is easy to use and comparatively other processor it has its own EEPROM and EEPROM devices. Consider the scenario for the 8051 architecture. A diploma engineering student is learning the 8051 microcontroller in the laboratory. The students want to interface LEDs, switches, and LCD and sensors for the new projects. Here, the problem statement is the students are difficult to understand the programming, hardware interfacing, and debugging because their existing learning methods are complex. And the main observation for this mini project statement is the students spend a lot of time checking wire connections, and many students confuse port, pins, timer, and interrupts. And the main what is the need for the students is a simple and visual way to learn instead of 5-1 architecture and step by step programming guidance to be needed for the students. Next one is internal architecture of 8051. So the main advantages of 8051 architecture are the overall system cost is very low and the product is very small in size and the system is more reliable compared to other processor. It has 8-bit CPU with register A and it has 16-bit program counter and data pointer and it has program status byte and it has 64K program memory as well as address memory. And the main architecture consists of two registers. One is B register and another one is status register. And the main important block is accumulator. Accumulator is nothing but it acts as a primary working register for the arithmetic as in logic unit holding data during the most calculation and logical operations and data transfers. This is the basic A accumulator and diagram of 8051 architecture. And next one is B register. B register is nothing but special function register. It is used to assist the accumulator during the 8-bit multiplication as well as division operation, and it also functions on extra temporary storage locations. From status byte, it is nothing but the special function register located at the address D0H, and it acts as a primary flag register and storing vital diagnostic information after the arithmetic logical operation and holding control bits for the working register banks. So this is the example diagram of program status byte. And next one is stack pointer. It is a stack pointer. It is an 8-bit special function register that controls the information RAM stack. It holds the memory address of the stack and top pointing on the last unit data location. It goes up into word memory. The data pointer is nothing but it is used to hold the memory addresses for accessing external RAM or ROM. It acts as this better during the indirect addressing operations. Here port 0 to 3 latches and drivers. So it consists of each port consists of internal D flop, a set of steady state buffers and output driver build up a transistor. This structure adapts depending on the whether they are handling standard I/O addresses or alternate functions and 1 and 2. Next one is serial data buffer. It consists of internal data as well as serial data points. So for the address I mentioned 0x99x. This is the example diagram of serial data buffer. It consists of shift register and special buffer register and special write register. And 8051 has special timing registers such as the timer 0 as well as timer 1. So the timer 0 diagram has been mentioned in this 8051 architecture, and TMOD and TM1 are the special timing registers used in 8051 architecture. And this is the control register. It has many components such as TCON, TMOD, and SCON, PCON, and IE and IP. The basic structure of control register are given in the 8051 architecture. It has two timing units. One is read unit as well as write unit, and it has both 8-bit register of input as well as output in the 8051 architecture. This is the internal circuit and external circuit bus of 8051. It has two oscillators, that is XTL1 and XTL2. It is nothing but crystal oscillator 1 as well as crystal oscillator 2. It generally high stable state and continuous clock signal. That is why it is used in the 8051 architecture. And instruction register are holds opcode operation for the instruction being executed in the 8051 architecture. And next one is EEPROM and EEPROM address register. So EEPROM address register contains a 8-bit processor and the EEPROM It's a track 0 to track 1 registers. And it has 4 memory banks such as bank 0, bank 1, bank 2 and as well as bank 3. This lower 128 bits are divided into 4 register banks and 8 at area and scratchpad RAM. The upper 8-bit register contains a special function register and it is used to control the peripherals. This is the ALU operation of 8051. So we have already discussed the logical operations performed in the 8051 are addition as well as subtraction, multiplication, division, and the primary registers are accumulator as well as register B. The special registers are program status pad where which has 3 to 4 bits to select which active bank for the currently utilizing the 8051 architecture. And finally the mind map of the 8051 architecture. So it consists of internal architecture, interrupts as well as addressing modes of 8051 architecture. Thank you for watching our video.